Okay, in this second video we're going to do applications of what we did with the polar form and component form. So again, on the last one, this is the little formula to get our component form. So y. Okay. So we're going to find the component form of a vector that represents the velocity of an airplane descending at the speed of 100 miles per hour at a direction angle of 210 degrees. Okay, so we have 210 degrees, so somewhere over here we've got this vector going down. That's its direction, and it's at 100 miles per hour, so that is our magnitude. Okay, so if we wrote this in component form, we have I don't know why I'm writing 100, 210 degrees. So we're just going to go straight to our formula. So we're going to go 100 cosine 210, 100 sine 210. Okay, so 100 sine of 210, I'm still in degrees, so negative 50, 100, oops, that was my sine, negative 50, and then 100, I did it backwards, cosine of 210, negative 86.6. Okay, so my vector, I'm just going to rewrite that. I don't know why I'm so sloppy this morning. So negative 86.6, negative 50. Okay, let's think about what this means. We had our x, we had our y. Both of them were negative. Okay, x is horizontal, vertical is, or y is vertical. So if we thought about this, what does this mean? We're talking about an airplane. Okay, who's descending. So for every and its direction, this is x, this is y, so this looks like how far it's dropping. If we think about this as slope, rise over run, rise is 50 over 86, or we think of it as it goes 86 in this direction. It's dropping down 50 feet that direction. Okay, but our answer would just be our component. Okay, okay. For our next application ones, we got to do a few things. First, we got to actually add vectors. In order to add vectors, what we need to do is find the component form first, and then we got to add the directions. Okay, so first thing we're going to do is we're going to put these in component form. So vector u is going to be 20 cosine 45, 20 sine 45. Okay, so we're going to change this to component form. So that would be, if I type that in my calculator, 14.14, 14.14. So there it is in component form. We're going to do the same thing here. We're going to go 50 cosine 150, 50 sine 150. Okay, putting this in our calculator, we get negative 29 point, oops, that's wrong. We get negative 43.3 and 25. Okay, real quick, let's do a quick thing. This one is in quadrant 1. Both should be positive. 150 is quadrant 2. Cosine should be positive, or sorry, negative. Sine should be positive. Okay, so all we're now going to do is take vector u plus vector v. And when we add those, what we learned last time is we just add like spots. So 14.14 plus negative 43.3. 14.14 plus 25. We're just going to add those together. So then our answer is negative 29.16, 39.14. So if we add those two vectors, that's going to be the resulting vector. Okay. The reason I did this example real quick is because when we use applications and we have to combine angles, different vectors and polar form is a lot harder than when we use component form. Okay. So let me see. I think I have one more example. I don't think we'll do one more example of those. We'll go quick. Sorry guys. Monday morning. It's the same no matter if you were here or not. Just slightly scattered brain. Okay. So we are going to go to cosine 30 to sine 30. Again, typing those in my calculator. I get vector V is 1.73 and 1. Okay. If you're not getting those, double check, make sure you are in degrees. Okay. On our second one, we would get 2 cosine 90 to sine 90. Okay. If you put those in, 2 cosine 90, you get 0. And you get 2, which should make sense because cosine 90 is 0, sine of 90 is 1. Okay, then if we add those, we're going to get 1.73, and then that's a 2. Yeesh. And then 2 plus 1 is 3. Okay. Other than me being unable to write things properly, it shouldn't be too bad. So let's see when we actually kind of use this. Adding vectors. So we have this situation. We have an airplane. It's traveling at a speed of 500 miles per hour. The speed is going to be your magnitude. Okay. So this right here. So we have a vector, let's say vector V, who has a magnitude of 500 miles per hour. Okay. And it has a bearing. Okay, we're going to use that bearing to get direction. North, east, south, west. So it's going north, 30 west. Okay, so north, 30 west. So this right here is 30 degrees. Okay, and its magnitude was 500. Okay, so there's our first scenario. And then if we look at, so that was there. Okay, with a fixed altitude with anyway, then the wind velocity blah blah blah, as the airplane reaches a certain point and encounters a wind blowing at the velocity of 70 miles per hour with the direction of north. Okay, so wind, now we have 70 miles per hour, so let's call that vector U. So 70 is it's going to be, what am I doing? Okay, and then its direction is north, 45 east. So this is 70. This is 45 degrees. Okay, so here's our situation. We've got the airplane going that way, and it's encountering a wind that's pushing it east, so it's headed west and it's getting a very strong breeze to the east. What we want to find out is if this wind is pushing it, where's the resulting vector? What's its resulting speed and direction? So we know what's going to be pushing it this way, so we'd expect the resulting vector to be somewhere between these two, because if we're going this direction and that direction, it would make sense it'd be somewhere in between. Okay, so what we need to do is find our component form for our two vectors. So if we look at this, we've got these angles, but they're not our reference angles. So we either need the reference angle or the complete angle, and I'm just going to do the complete angle. So this would be 90 plus 30, so 120. So for vector v, we're going to go 120 degrees, or sorry, first comes our magnitude, 500 cosine 120, 500 sine 120. Okay, and if I put that in my calculator, I am going to get something. Okay, I'm going to get negative 250 and 433.01. Okay, so there's my vector v, my airplane's component vector. Okay, let's do my wind, my wind's vector. So that I called was vector u. So if I look at this, if this is 45, then this also right here is 45. So 70 cosine 45, 70 sine 45. So vector u is going to be 49.5, comma 49.5. Okay, so now we're going to take those two and we're going to add them together. So we're going to take vector v plus vector u. So I'm taking my airplane's vector, direction, and speed and adding it to my wind's direction and speed. So negative 250 plus 49.5, 433.01 plus 49.5, and we get the resulting negative 200.5, comma 482.51. Okay, so that is where my airplane's resulting speed and direction is. However, in this form, the only thing it tells me is it's somewhere over here. It doesn't actually tell me its speed or its direction, its angle. So what we need to do is we need to change it back to a polar form. Okay, so we have its x, we have its y. So what we need to do is we need to find first its magnitude. Okay, and I'm going to call this vector A for our airplane. Okay, so I need to take the square root of negative 200.5 squared plus 482.51 squared. Okay, so I'm going to type that in my calculator, take the square root, and I'm going to get 522.51. Okay, that's its magnitude, so that's its miles per hour. Okay, so there is the speed of my airplane, my new direction. Okay, and then we need to find our, so we found this, so we need to find our angle. So we have our x, we have our y, and we want to know theta. So I'm going to do cosine because it's in this quadrant. Sorry, we're going to come over here. So I'm going to take cosine of theta equals my y, my opposite, sorry, cosine, adjacent over hypotenuse. Adjacent is negative 200.5 over hypotenuse 522.51. Theta equals the cosine inverse of that. Okay. And I get theta equals 112.56 degrees. Okay, so my new purple vector, my vector A, has a magnitude of 522.51 with the angle 112.56. Makes sense, that should be about 112.56. So that means that it has 522.51 miles per hour with, we need the direction. So we've got our angle. So let's think about this. If this right here is 112.56, so what we're going to do, let's subtract 90 degrees from that. So if it's going to be going 90 degrees would be north. If we subtracted that, that gave us 22.56. So it's going 22.56 more than straight north. So that would be north 22.56 degrees west. Okay, that one was quite intense actually. Yeah. Those are probably the most intense ones you guys have. Let me know if you guys have questions, and good luck. Sorry, the videos went long.